course, in this video, we will be solving the multiple choice questions, which is the 2018 paper. All right, so in part 1, there are 30 questions and no calculators are allowed. And in part B, there are 15 questions with calculators. All right, so let us get straight into this. Remember, if you're doing AB or BC, you should be able to practice these questions. All right, so let's have a look at the first question. So the first question says, if f is the function given by f of x, if f is a function given by f of x, which is 4 over x plus 5x minus 1, then find the derivative evaluated at 2. Right, so you want to find the derivative evaluated at 2, right? Good. You can't use a calculator, so we need to say f of x. Rewrite the function 4x to the power minus 1 plus 5x minus 1.
So it will be minus 4x to the power of negative 2 plus 5.
And then we're evaluating this at 2.
Yeah. So
minus 4
2
over
times
4 plus 5. Because 2 to the power minus 2 is 1 over 4. Right? Are we good?
No,
so
you just put minus 4 over x minus 2 in the denominator, and then you evaluate that. It will be 2 to the power of negative 2 is just 4.
Yeah, so 2 to the power negative 2.
Yeah. 4, yeah. So it's 6.
No, minus 1 plus 5 is 4.
My bad. 4.
Right, excellent. Right, excellent. Let's integrate this. If we're going to integrate this, you know how to integrate e to the power mx. It's e to the power mx over m plus c. So this is just going to be 6 e to the power 3x over 3 plus c. 6 divided by 3 is 2. So 2 e to the power 3x plus c. Okay?
Yes.
Simple question, sir.
Yeah, because you have to divide by 3. 2 e to the power 3x plus c. Yeah. Next question.
Well, they always start
question
like 3. That.
Yeah, it's easy. Let's question 3. The graph of y equals f of x is shown above. What is limit as x approaches 1 of f of x?
The limit does not
exist. It does not exist because the left-hand side, because it's left-hand side, right-hand side limit approaching different values, so the limit does not exist. Easy.
And there's jump discontinuity.
Yeah, jump discontinuity at x is equal to 1. Excellent. Question 4. If f prime x is equal to this, right, and f of 2 is equal to 3, then f of 1 is equal to, so first you need to integrate, right, because you need to find f of 1. So you need to find
opposite
f of x. Yeah. Integral 3x squared plus 2x, right? You're going to integrate
3x
this.
the power of
x cubed plus x cubed squared.
Plus x squared, yes.
Plus c, which
then
is f of x.
Yeah.
F of 2 is 3.
3, yeah.
F of 2 is 3, so that's 8 plus 4 plus c is equal to 3.
12, but 3, sorry.
So 12, so 3 minus 12 is negative 9. So we
9,
got a full function. So we got a full function f of x, which is equal to x cubed plus x squared minus 9. Substitute 1. If you substitute evaluated at 1, you're going to get 1 plus 1 minus 9, which is negative 7. Right. Excellent.
A little bit tricky, but easy.
No, not tricky. Just antiderivatives and substituting the initial value problem and then solving the problem. Okay?
Yeah, basically.
Great. Good stuff. Yeah, next problem. During an evacuation drill, people leave the building at a rate of R of T, people per minute. So R of T is already the rate, where T is the number of minutes since the start of the drill. Selected values of R of T are shown in the table above. Use a Riemann sum. Remember, this is already a rate. If you integrate a rate, you get like displacement or what you call area. So what is approximation? Sorry, if you integrate a rate, you should get like a position. What is approximation of the number of people who leave the building during the first 15 minutes of the evacuation drill? So I'm going to write it out. So the integral from 0 to 15 of R of T dt, right? You approximating a Riemann sum. So what is, let me draw a simple graph for you to explain what this here means, all right? because you need to understand what you are doing, right? So, right, so obviously there's 0, 5, 10, 15, 0, 5, 10, and 15. You can see you have equal widths of the rectangle. The first one is 100, right? The second one is also 100. Actually, at 0 is evaluated at 100. Second one is 100. Third one is what? The third one is, wait, at 5 it was 100. At 10 it was 75. So there should be 75 there, right? And the third one, 15, is 55. So I'm just approximating. So that's 55, right? That is 75, and this is 100. Right? Riemann sum means you must find, if you take the difference in the x values, you will get the width. In this case, it's just equal widths, so that's nice. Sometimes you may not have equal widths, so it's fine. So you're going to take the equal widths, right, and multiply these by these height values, right, Riemann sum, okay? You're going to take the equal width here, multiplied by this value. Then you take the equal width here, width times height, right? Because the function values gives you the height. Now, if you're doing left Riemann sum, you're going to take the equal width and multiply by 100 and leave the last value out, okay? This is because this is right, evaluate from the right, leave out the left value. If you're doing left Riemann sum, leave out the last value, start evaluating from the left. So this is easy. You're just finding the area. So basically is 5, 0 minus 5 is 5, 5 times 100, plus 10 minus 5 is 5, 5 times 75. You can see I took this value, then 5 times 75, right? Plus 5 times 55. Right, so we're just going to add it up because there's no calculators allowed. So that's 500 plus 5 times 75. We know 4 times 75 is 150, 300. So 375 here, right? 5 times 50 we know is 250. And then 5 times 5 is 25, 250, so 275, right? Yeah, that should be fine. Now, 375 plus 270, 75 plus 75 is 150. Then you got 500 plus 300 plus 200. That's 1,000. 1,000 plus 150. So 1150. So B. Are we good? Makes sense, guys?
Teacher, if for example they will say find first 10 minutes, so our equation will look like just 5 times 100 plus 5 times
Yes.
75.
Yes. But usually they ask for
Nice.
the whole thing from 0 to 15. Right, excellent.
Okay, I
Right.
got you.
Let's find this dy dx of this function. So what we're going to do is we're just going to differentiate this, right? But it's better to open it. Let's not open it up first. So let's just find the derivative. Derivative of, what's this, product rule? Derivative of x squared is 2x. Leave the second. Plus the derivative of the second bracket is just e to the power x, and then leave the 2x, okay? So you got 2x e to the power x minus 2x plus 2x e to the power x. Now remember, these things are common, 2x e to the power x and 2x e to the power x, okay? So that will be 4x e to the power x minus 2x. 4x e to the power, they don't have it here. Oh, wait. Why did I differentiate both? Sorry, guys. Yeah, so because we're given multiple choice, all right? So let's see, e to the power x minus 1 derivative and then times x squared. You should end up with 3 terms. So there's no like terms here.
X squared, yes.
Yeah. Plus x squared e to the power x. So 3 terms, x squared e to the power x plus 2x e to the power x minus 2x. Should be C, right? We have an answer. Are we good?
Yeah, it should be C, yeah. Positive x squared, yeah, it should be C.
Yeah. Next one. A particle moves along the x-axis so that at any time t positive, its acceleration is given by this function, right? So this is an acceleration function. If the velocity of the particle at t equals 0 is 7, so in other words, v of 0 is 7, and its position is x of 0 is 0, then its position at time t is x of t. You want the generalized function, what is a position function? So obviously, first you're going to find the velocity by integrating the acceleration, okay? So if you integrate the acceleration, which is minus 4 sine 2t dt. If you integrate this, you're going to get negative 4.
Positive for
What's the
sine,
integral of
positive,
sine?
no? Positive, it will be
No,
negative
what's the
cosine, so you can positive cosine.
Yeah, good. Yeah. I'm just leaving the -4 as it is. I'm trying to integrate sine 2t. Very good though.
Oh yeah, my bad. Yeah.
Negative cos 2t. No, you're right. I just like to do it in steps. Leave the -4 and then do it, then divide it by 2. Don't forget to divide by 2 plus c. Now they told you that v of 0 is 7. V of 0 is, what is cos of 0? 1.
1.
So -4 divided by 2 is 2. 2 plus c is equal to 7. This implies the value for c is
Negative,
c is
positive 5.
positive 5. So now you have a velocity function. Now you're going to integrate the velocity and you get position function, which is x of t. So integral of velocity is 2 cos 2t plus 5 dt. We're going to integrate this. So you're going to get 2. Integral of cos is sine, right? Because the derivative of sine is cos.
Yes, yeah.
So sine 2t divided by 2 plus 5t plus another constant. And they told us x of 0 is 0. X of 0 is equal to sine of 0 is 0, 0, 0. So the value for c is also 0. So if the value of c is 0, you can remove c, and this is your function. Your function is sine 2t plus 5t.
So A.
Yes, very good. All right, good guys. We are doing well on time. Remember, you're supposed to finish this in how many minutes? 1 hour. Yes. So you're supposed to spend like at least 2 minutes per question. Obviously, some questions are much faster. You can save some time for the more difficult question. All right, so now what we have?
Mister, can you go
We
back
have
up
a
to the
double.
question above? I just want to see something.
Yes.
Wait.
What's the problem here?
And there's just something I don't get. I'm trying to understand it.
You're
Wait.
just substituting the initial condition to solve for the constants. Every time
For
you
the constant,
integrate,
yeah.
you get a constant. Yeah, you get a
Oh,
constant.
yes. Okay.
Because the value of c is 5, you're going to put the 5 back inside c there. And then you're going to
Yeah.
integrate this function. I said -4 divided by 2. Positive 4 divided by 2 is 2 cos 2t plus 5. Then I integrated this. Remember, 2 divided by 2 is 1. So you just sine 2t plus 5t. So the answer is A. It's correct. Well, let's get back here to this function here. Look at this function, all right? It's an interesting question, right? So first of all, the derivative. The graph of f double prime, the second derivative of the function f is shown above. Which of the following could be the graph of f? First of all, this is y double derivative, which is x squared. So in other words, the original function is x to the power 4 plus whatever. It's a power 4 function. So can it be a? It's a cubic function, right? It can't be a. Can it be b? It can't, because this is a negative cubic function. Okay. So a and b is out. So it's nice because now we know it's a power 4 function. So it looks something like c or d. Right. Now let's observe. Maybe it's a positive power 4 function. Why? Because this is a positive, right? And this is a
So it's a
positive. You
positive,
can
will be,
see.
yeah.
So I don't think it's this one. Maybe it's D. But let's observe D and see if it actually works. Let's observe D. Remember, they gave us some points here. So this point over here is -1. Okay. Now, if I ask you, where is this graph? This is a graph of F, right? Now, where is this graph concave down? Is concave down coming from, it's less than, it's probably less than -1, isn't? No, concave down will be looking at, this is actually concave up, going from here right up till maybe 0.5. Looks like there's an inflection point here, right?
So it's
And looks
0.
like there's an no, at half. At half,
Oh
the
yeah.
graph is changing concavity. In other words, there's an inflection point, okay? At half and negative half. So let me draw this in another color. You can see, all right? And then the graph goes back up to concave up after another point, which is half, okay? So let's just say this point is negative half and this point is half. So between -half and half, the graph is concave down. Less than -half, the graph is happy. And after half, the graph is happy. Happy means concave up. Now let's observe this graph. This is already the double derivative. So if the double derivative, you can see is intersecting at like half, maybe 0.75. Okay, I'm just estimating it. I'm just saying it's half because 1 is there and -1 is at the end. You can see the double derivative f double prime greater than 0. When is f double prime greater than 0? Less than -half, isn't? And after positive half. So is this top part of the function here because you're observing double derivative. Okay? And where is double derivative negative? Where is f double prime less than 0? Is between this interval here. See this bottom interval. Okay? So it conforms to what we have just discussed in part D. You see, less than -half, this graph is happy, right? Between -half and half, the graph is sad, and then after half, the graph is happy. So let's see if between -half and half is the graph below the x-axis for the double derivative. Yes, it is. Now, if you try to observe this, this is telling me 1 is here and 1 is here. What this graph is telling me is that between half and -half, the graph is happy, which is wrong because between -half and half, the graph is below the x-axis for the double derivative, which means the graph is sad. It needs to be a sad graph between, it needs to be a sad phase between -half, but this is happy, so it can't be C, right? So the best option is D, and we'll choose D as the answer. Okay. Right, great, guys. Let's move on to the next one. When x is equal to 2e, what is limit as h approaches 0 of this? Now, this is coming from first principles, and your function is ln x. So if f of x is ln x, how would I write down the first principles formula? If f of x is equal to ln x, what's my first principles formula? F prime x is equal to limit as h approaches 0, f of x plus h ln x plus h minus ln x minus f of x divided by h. But we're not going to do that because they just asked us to evaluate this. So we're just going to differentiate this, not use first principles to differentiate. So if you evaluate f prime x, you just get 1 over x. And now you're evaluating this limit at x equals 2e. So it's f prime 2e, which is 1 over 2e. Are we good, guys?
It's just easier, so yeah, simple.
Yeah, it's easy. Remember, it's first principles formula. Who has joined here? Sultan, you understanding? Excellent. Right. What you need to do here is for question 10, you want to find the triple derivative evaluated at x is equal to 2. Come on, man, it's easy stuff. It's just polynomial function. So what's y prime? Oh, wait, y prime is already given. What's y double prime? 4x
cubed.
Yes.
Minus 6x squared plus 3.
And then triple prime?
Is 12x squared.
Good.
Minus 12x.
That's it.
That's it.
And we're evaluating it at x is equal to 2. Give me the answer. So 48,
So
12 times 4.
48
minus 24.
So 24.
Yes.
Very good. Easy peasy. Right, excellent, guys. Let's move on to the next question. Let f be the function defined above. What is negative 1 to 1 of f of x? Now, very important, when you're evaluating split functions, you're going to evaluate it like this at all 3 different intervals. Because, and what are the 3 different intervals? Let's put it here. The 3 different intervals are, you're starting at 0, right? Yeah, it's just greater than 0. But look, not that interval there. I'm looking at this negative 1 to 1. If I put negative 1 to 1, if I'm evaluating this integral from negative 1 to 1, remember there's a split in between, there's a 0 in between. So you're going to evaluate 2 different integrals, one at 0 and from 0 to 1. So this integral here, integral from negative 1 to 1 basically becomes integral from negative 1 to 0 plus 0 to 0 plus, because there's 3 parts of the function, plus 0 to
1.
Right. Now 0 to 0 is just 0. This answer is evaluating at a point. That's out. Yes.
Isn't I thought 0 to 0 is just an indefinite integral.
No. Integral from 0 to 0 is just 0. You're not evaluating anything.
Okay.
There is no area under this. So it's
there's no area. Yeah. So now if you're evaluating from negative 1 to 0, you're actually integrating the first part, x squared. So if you're integrating squared is just going to be x cubed over 3 from -1 to 0. Plus, if you're evaluating from 0 to 1, you're evaluating greater than 0.
X squared. X squared.
X squared over 2 from 0 to
0
1.
to 1.
If you substitute 0 on the upper
1.
boundary, you're going to get 0 minus, you substitute -1 inside here, you will get -1/3.
-1.
Yeah, so positive 1/3.
Yeah, it's plus, if you substitute 1 inside here, you will get half.
Just get 1.
Substitute 0,
Half.
0.
0.
So what's the answer? 1/3 plus half. So the
It's
answer
a
here,
5/6.
good, 1/3 plus half, which is 6 here. Butterfly method, 2 plus 3 is 5/6. Excellent.
Easy. Let's go.
Right, excellent. Question 12. Given that 3x minus tan y equals 4, what is dy dx in terms of y? So, in order to evaluate this, we got to differentiate, and y is a function in x. So you got to evaluate implicitly, okay?
We
So when I
can't,
say
Mr. We can't use implicit here.
we have to, because it says dy dx. Y is a
But-
function in x.
but-
Y is equal
but-
to y of x.
But doesn't implicit only work if we have y on both sides of a function?
Not necessarily. You can have a constant on the other side. They said evaluate dy dx. So let's evaluate this function. If you differentiate 3x, you get 3. If you differentiate tan, you get
Is
sec,
sec x tan x.
no, sec squared.
Ah, yes,
Derivative of
yes,
tan
yes.
is sec
Sec squared, sec
sec-
squared, right.
Sec
That's my
squared
bad.
y times y prime equals derivative of 4 is 0.
0.
So what's y prime? Y prime
Y
is
prime
take
is
the 3 over, becomes -3 divided by sec negative sec squared y. But now sec is 1 over cos reciprocal, so
Exactly.
it becomes 3 cos squared y.
Square y. That's it.
B. Excellent, guys. Nice. I'm happy. You guys are
We're
flying.
just
with these
taking
things.
the derivative, yes, sir. Yeah, we're
Yes,
just taking
we
the
just-
derivative, and that's it.
Yeah, but implicit. Remember, the set must find dy dx. In other words, y is a function in x. Excellent.
Okay.
For time t greater than 1, the position of the particle moving along the x-axis is given by p of t. At what time t in the interval 1 to 16 is the instantaneous velocity? What is the instantaneous velocity? P prime t.
at a point.
Yes, it's exactly at the point. That's instantaneous at the point is equal to the average velocity. Average velocity means y2 minus y1 over x2 minus x1. Okay.
Exactly, yeah.
In
Delta.
other words, it means, right, so you got the point 1 and 16. So you need to set up an equation. You need to say p prime t is equal to p of 16 minus p of 1 divided by
16 minus 1.
right. What is p of 16? Substitute here.
2. 2.
Oh,
because-
2, yeah.
2 p of 1
-1.
negative 1. So it become -1. Be careful. Don't skip steps.
Yes.
16 minus 1 is 15.
50. So it's
What is
3
p-
over 15.
No. What is p prime t?
So 1/5.
No. What is p prime t? I'm asking you,
Oh,
what's p
yeah.
prime t?
1
You
over
need to
2
solve this.
times -1
One
over
over-
2.
1 over
the
2
power-
root t. Yes.
Yes, exactly. Just like this.
1 over 2 root t. So now this is 3 over 15. What's 3 over 15?
1 over 5.
1 over 5. And that's 1 over 2 root t. You need to solve for t. Flip both the
Just make
fractions.
them equal. Yeah. Denominator
Flip-
goes to denominator, yeah.
Yeah, flip both the fractions. So 2 root t equals 5.
So 25 D.
No, 5
Oh,
over 2.
no. Wait. Hold on.
Root 2, the root t equals 5 over 2. So t equals square both sides. So 25 over 4.
Exactly.
Okay, guys.
Oh, see,
Yeah.
yeah.
Right, excellent.
We
Nice,
need to
nice,
square
nice.
root at both sides. That's it.
Yes. Not square root, square.
Square. So yeah, square. Just square both sides. That's it.
Yes. We are doing AP math. You need to be precise about what you're saying. Right. If f is a differentiable function and y is equal to sine f of x squared, what is dy dx evaluated at x is equal to 3? Now, it's very important how you differentiate this. This is a composite function. So you start differentiating from outer ones, leave the inside, then differentiate f, then differentiate x squared. Okay. So you're going to say y prime is equal to differentiate sine of the whole thing. What you get? Cos of the whole
Negative.
thing.
Cos.
Yeah.
You get differentiate sine. You get cos,
F prime.
Negative cos.
not negative
No,
cos.
no.
Cos.
If integral of the sign is negative cos, but there is
Yes.
differentiation here.
Remember,
So
if you different,
F
if
prime.
you Mhm. So cos f of x squared. Hey, if you differentiate anything starting with a c, then it's negative. Okay, remember that. What's the derivative of cosec? Negative cosec cot. What's the derivative of cot? Negative cosec squared. What's the derivative of cos? Negative sine.
Negative sine.
Everything starts with a c, so it's negative. Now we're not differentiating something starting with a c, so it's sine cos f of x squared. Now differentiate the inside. It's f prime x
X
squared.
squared,
Now differentiate inside.
2x.
Differentiate. Yes, that's it. Now what is
2x.
evaluated at 3? What is this evaluated at 3? So y prime evaluated at 3, just substitute 3. So that's cos
Cos of f of
f of
9.
good.
F of 9 times f prime of 9
Times
times 6.
6.
6.
Just 6.
So what's the
Oh, so
final
D.
answer? 6. 6 times f prime. Yes, very good.
D, right?
Wasn't difficult. Simple stuff.
No.
Right, next question. The graph g prime, the first derivative of the function g, consists of semicircle of a radius 2 and 2 line segments as shown in the figure above. So there's a line segment up and then line segment down. If g of 0 is equal to 1, if g of 0 is equal to 1, what is g of 3? In order to find g of 3, right? To find g of 3, let's try it, because they gave us g of 0 and g of 3. Remember the integral from 0 to 3 of this entire function. But remember, we're only integrating from 0 to 3. Look at this block here, right? Integrating that piece here. So to integrate this, we're going to say integral from 0 to 3 of g prime x is equal to g prime x dx is equal to, by using fundamental theorem of calculus, what do you think this is? This is
G of
G
3
plus 1.
minus G of 0.
g of 3 minus g of 0. Very good. I should have used a small g here, right? G of 3. Now use this equation to evaluate this. Now,
G of 0
I'm
is
gonna say,
given.
1 second, 1 second. Yes, very good.
So-
G
so
of
there's a-
3. Yes.
There's an easier way you can solve this.
Yeah, we are going to do the easy way. This is your starting point. If you don't
Okay.
get this starting point right, then you're going to mess everything up. So
Yeah,
now
yeah.
g of 3, we want to evaluate g of 3. So we're going to say g of 3 is equal to integral 0 to 3. But you can't integrate from 0 to 3. It's not a one full function. It's different function. There's a quarter circle plus area of triangle. Isn't? So you're going to
Yeah.
integrate from 0 to 2 of g prime x dx plus integral 2 to 3 of g prime x dx.
Yeah. So
And
then
when
you
you
would
move g
have
of 0, wait, 1 second. If you move g of 0 over g of 0, someone said it was 1, it was given, good. If you move this minus 1 over, you will get plus 1. Now this is
Yes.
just pi r squared divided by
4.
4. Yes. Pi
So
r
pi
squared
r
divided by
squared
4
over 4
when r is
evaluated
equal to
from
2. When r is equal to 2.
2.
So now you see 2
So
squared is 4, 4 over 4 cancels out.
pi.
Good.
So pi
The
plus
answer is
1.
pi there. Wait 1 second. And what's the area of the
Oh, yeah.
triangle here? Half. You don't need to
Half
evaluate this
base,
base
which
times
is
height.
1 times height is
Yes.
2, so it's just 1.
No. It's 3 over 2.
Mister, the height is 2.
Oh yeah, the height is 2. The height is 2. Sorry. Thank you. Height is 2, so which is 1. So you
Which
got
is 1, so it's pi plus 2,
pi plus 2. Very good.
which is b.
Answer is B. Excellent. You understood this whole thing. Make sure you understand.
Yeah.
You can't integrate over the entire boundary because you got different functions to integrate.
Teacher,
You
I
integrate
have a question.
yes.
So 2 to 3 is the half of the triangles area,
Yeah.
isn't it?
Half half base times height.
Okay, but the
It's just a
original formula
triangle.
of the triangle is also half times height times base, isn't it?
Yeah, half base times perpendicular height. The height must be 90-degree height from the vertex.
Oh, okay.
Because if you're looking at a
Yeah,
general
fine.
triangle, for a general triangle, area of the triangle is half AB sine C. Then you have to use trigonometry if you don't have the perpendicular height. Right, let's move on to the next question. Let f be the function defined by this. What is the maximum value of f on the interval 0 to 6? Maximum value of the... So to find the maximum value, you need to find the derivative f prime x,
Exactly.
which is 3x squared minus 12x minus 15 is equal to 0. So you're getting x squared minus, simplifying, putting in quadratic form.
Yeah, 4x
Simplest combination.
minus
4x
minus 5.
5. So now we got x,
Positive 5, negative 5 and positive 1.
x minus 5, x plus 1 equals 0. Now x is equal to 5 or x is
Negative
equal
1.
to negative 1. Now
Negative
what are
1.
these? These are turning points, and this is a positive cubic function, so it goes like this. Right, so now we know that the turning points are here at negative 1, which is a maximum, and at 5 it is a minimum. Now
Minimum.
we can reject x equals negative 1 because we're not looking into that. Okay, we're only looking at between 0 to 6. So 5 is between the interval 0 to 6. Now, how do you know whether it's maximum value or minimum value? What substituting 6 in there now?
Yeah, we
They ask for
substitute
what?
6
You
in
need to substitute
the...
the endpoints. Endpoints. We never check endpoints.
Yeah.
Endpoints, x equals 0 is going to give us 0.
Negative 15.
Y value is 0. And if you substitute x equals 6, it's going to
You
give
will
us
get 6 cubed
Oh,
minus
yeah.
6.
6
What's 6
cubed.
cubed? 6 times 6 is 36.
No.
36 times...
6 cubed. 6 cubed minus 6 cubed is 0. So
Yes,
minus
exactly.
15 times 6 is just minus 90. Yes?
Wait.
Yes,
This may be a
yes.
stupid question, but why is it x minus 5, x plus 1?
Oh, okay. Because the product of minus 5 and 1 is minus 5, and minus 5 plus 1 is minus 4. So this, remember,
I
this
thought it was
gives us
the
this. This gives
thought it
us
was the
this.
0
other
is
way around.
maximum. Teacher, 0 is maximum, yeah? The answer is A.
Yeah.
Why are you saying that? Why are you saying that?
Because 0 is will be below the function, isn't it? And negative will go downward. So
Yes,
maximum
because
is 0.
they didn't ask for the relative maximum. Relative maximum will be at this point. Good. So at 0, no, what about 5? What about the value of 5? We never substitute 5 inside here. What's f of 5? Y equals, if you
5
substitute 5,
cubed is
125.
125. 125 minus 30 squared will be 3 times 3 is 600.
No, wait. What are you doing?
How 30 square? No, 25 times 6.
So
Yes,
negative
It cannot be
25 times
30 squared. Yeah,
minus
25
150, 125 minus 150, and another minus.
minus 75.
So all these are giving
Again
us
negative.
negative
Again
values.
negative.
So
So
Minus
the
maximum
answer
is
is
0.
100.
The answer is 0. Good. Because
That's it.
they ask for the maximum value between the intervals. So it occurs at the endpoint, not at the relative minimum and maximum. Okay. So it's basically at x is equal to 0 is an absolute minimum. Absolute maximum.
Exactly.
Yeah. Just look into that, right? Let's look at the next integral. The integral is from 1 over x squared plus 4x plus 5. So obviously this here looks like some arctan form, right?
Yes.
Remember, integral of 1 over x squared plus 1 dx is equal to arc tan x plus c. That's your rule. Now you need to convert that. Maybe I can break up the 5 into a perfect square, right? So I've got x squared plus 4x plus 4 plus 1. Why plus 4 plus 1? Because I want to make it into a square.
Exactly.
4 plus 1 is 5. So this is already x plus 2 all squared plus 1. You can make u equal to x plus 1. So you got du is equal to dx. So now the integral turns into integral of 1 over u squared plus 1 du, which is equals to arc tan u plus
U
c.
plus
What is
1.
u?
Sorry, plus
X
C.
plus 2.
X plus, oh, sorry,
X
this
plus
was
1.
x plus 2, x plus 2,
X
x
plus
plus
2,
2.
yeah.
This was x plus 2, x plus 2. Arctan x plus 2 plus c. Are we good? That's our answer.
Yeah, yeah.
Obviously, it can't be arcsine. Arcsine is the square root forms. It can't be ln because if you differentiate ln, you're going to get 2x plus 4 on top and this part at the bottom. It can't be this. So they give you some nonsense options as well. All right. Obviously, you could have differentiated the answer, the first answer, to check whether if you get the same integral, and you will. Right, question 18. Guys, you guys are flying. It's not even half an hour. Right, let's look at this. Let f be the function defined by f of x is equal to cube root of x. What is the approximation for f of 10 found by using the line tangent to the graph of f at the point 8 and 2? Right, so now you want to approximate f of 10, right? To approximate f of 10, we can say f of 10 is approximately equal. No, what's the formula? What's the equation of the tangent line? Wait, let me write down the whole
Y
formula.
minus y1 is equal to
yes,
the slope
m
times x minus x1.
yes, x minus x1. Now you want to approximate f of 10. In other words, the value is 10. So remember, y is f of x, right? And what is y1? Y1 is the point
2.
8 and 2. So that's minus 2 m x minus x1. X is already 10, right?
No,
And
it's
what's
8.
x? No, x1 is 8.
Oh, yeah.
Let me put it here. This is x minus x1 is 8 because the coordinate was given 8 and 2. That's x1, y1. So this
Yeah.
is 2. So you have f of 10.
8,
Remember, you're
sir.
That's
evaluating
8,
10.
8.
8. Thank you. Yeah. Good. Now you're evaluating f of 10. So f of 10 is approximately equal to, you take the 2 over, you get 2 plus, let's put x minus 8 here. The only thing that we need to evaluate is the m value. So I need this m value here. What is the m value? The derivative evaluated at 10. So we need to find f prime x. F prime x is d dx of
She's just
x to the power
1 over
1/3.
3.
X to the power negative 2 over 3.
Yes.
Are we good?
So slope is 1 over 3.
No. Why are you saying the slope is 1 over 3? The slope is not 1 over 3. The slope is 1 over 3,
slope is
x
the
to
whole
the power
thing.
negative. You need to still sub in this point here,
Oh, yeah,
which is
yeah,
8.
right, yeah.
So f prime 8, which is 1 over 3. Change the 8 to 2 cubed. So the 3 and the 3 cancels out. You're going to get 2 to the power
So
negative
it's
2.
4 over 3.
12.
No. 1 over 3 times 1
It's
over
4 over
4
3.
is negative. No. This is
Because
2
it's
to the
2,
power
it's 2
negative 2.
squared. Yeah, it's
Yeah,
negative 6
1
over
over
3.
12.
Negative.
Oh, yeah. 1 over 4. So 1 over 12.
1 over 12, right? So
Yeah.
now you're trying to substitute. Remember the x value was 10 there, right? So I forgot to write 10 here. So this answer is now equals to 2 plus 1 over 12. 10 minus 2 is 2.
Wait,
This
why
is
10?
2 plus.
It's given, yes.
You're
Okay.
evaluating at 10, yeah. 2 plus
2
1 out of
plus
6.
1 over 6, which is just 2
13 out of
13 over
6.
6.
13 out
2.
of 6.
13 over 2.
Because multiplying by 6, come on, man.
Yeah,
2 times
yeah,
6.
you'd get 1. You'd get 1
Sorry,
on 12 over 6.
Yeah, multiplying by 6. So
Yeah,
12
right.
plus 1.
Okay, let's move on.
Let's move on. Right, so let's see. Limit as x approaches 0. I like this because mixture of polynomial and e function. See if you're getting 0 over 0, then you can use L'Hopital's rule.
L'Hopital. Yes, we get
So
0
we should
over
check.
0.
We should
Let's
check.
check. Let's check. 0, we're getting 0 on top. E to the power 0 is 1. That
1.
is 0. 1 minus 1 is 0. So we're getting 0 over 0. Let's
So it's like
differentiate the
plus 2.
top. Differentiate the top, you get 8x. Differentiate the bottom, you get 4 e to the power 4x. Don't forget to differentiate the power as well. Minus 4. Are you still getting 0 over 0?
No.
Substitute, yes, you are. E to the
Yes,
power
you are.
0 is 1.
So
4 minus 4 is 0. Getting 0
Oh,
over 0
yeah,
again.
4 times 1.
Differentiate 8. You get 8
8
over
over
4 times 4 is
16.
16. 16
E to the 4x.
e to the power 4x. That's it. Now substitute 0 inside.
So it's 8 over 16. So 1
8
half.
over 16.
So 1/2.
Good. Excellent.
Nice.
Good. You must check for that. Infinity over
Mister,
infinity or
wait,
0 over
Mister.
0? Come on. What's the derivative of e to the power mx? ddx of e to the power mx is e
M
to the
times
power,
e to the mx.
yes, times
Yeah.
m. Times m, not times mx.
Yeah, times m. Yeah, sorry. Okay, let's move on.
Are we good, guys?
Yeah, yeah.
And let's move on to the next question. Let g be twice differentiable increasing function. Very important. Let g be twice differentiable increasing function. You already know about these types of function. Let me just choose a function, maybe an exponential function. I'm just giving an example. If I choose an exponential function, like e to the power x, it is differentiable twice and is increasing, isn't?
Yeah.
It doesn't need to be like this. It can also be going concave down. I just put it
So
concave
when they
up.
say differentiable twice, it means that you can find the double derivative of the function, right?
Yes, yes, correct.
Okay.
And if g of 0 is 20, let me just put 20 here, right? And if g of 10 is 220, so you got 0 and 10, and that's 220, right? Which of the following must be true on the interval 0 to 10? Which of the following must be true?
So this is
Now,
IVT.
not IVT. Look at, they're talking about derivatives, right? So this is more like mean value theorem, right? So you look more like slopes. So you're going to say g prime, okay? You're going to say g prime t is equal to g of 10 minus g of 0 divided by 10 minus 0. Okay? Now, it's more like mean MVT, right? So you can look into the theorems. It's definitely not IVT because you're talking about derivatives.
Yeah, yeah.
Next one was g
So
of
you
10. G
get
of 10 is 220. What's
220
g of 0?
minus 10,
20.
20 over 10. It's just equal to 200 divided by 10 is
18.
20.
20. So which one of them must be true in the
No,
interval?
it's
G prime t.
200 minus 20. Oh, 220 minus 20. Okay, okay.
Yeah, yeah. So
So B1.
G prime t is 20 for some interval t in the interval.
So
Yes.
B.
Yeah,
It can't
it's
be
B.
G prime t can't be equal to 0 because they say it's
No.
differentiable twice and it's
Yeah.
increasing.
And the
So
double
this is
derivative
nonsense.
is just wrong. The double derivative
Yeah,
is
double
just wrong.
derivative. Yeah, because they said it's twice differentiable increasing. Yeah, there's none of those options. Okay, let's move on to the next
Mister,
one.
wait. When you said twice differentiable, the graph of the exponential function, is that the graph of f prime?
No. I just chose a function. I just found that I just said let the
I meant like,
let this
yeah.
information be like some function e to the power mx.
Yeah, I know, but I'm just asking if they tell us a twice differentiable function, should we graph f prime or f?
No, f.
F.
Yeah, because they said they gave us two important information: twice differentiable and increasing. So this is increasing and is twice differentiable. You can have a function like this, or you can also have another function like this. You can also go, but this will become decreasing. No, you can't have
Yeah,
decreasing.
it
You
cannot
can
No,
be.
have
it has to be
concave up.
concave up. Yeah, it
Yeah,
has
it
to be
has to be
concave up.
so it's till there.
So Zari,
Yeah. You have
how
a
can we
question?
find the double derivative in case we get a problem that asks for a double derivative? Like problems like these.
You can't find the double derivative here. I'm just giving you a classical example of an exponential function where it is twice differentiable and is increasing. I'm just choosing
So it's a
known
red herring.
functions that, yeah, it's
Oh, it's not
basically, I'm
possible.
just,
We don't have a
no,
function.
yeah, we don't have a function. I'm just choosing known functions that I know of.
Yeah, okay.
You don't really know. Right, next one. Right, so what is this? This is fundamental theorem of calculus. You're going to substitute x cubed. You're finding the derivative of an integral. You're going to substitute the upper boundary inside, differentiate that. Then you substitute minus lower boundary substituted and differentiate e. You're going to get 0. So if you
Yeah, simple, sir.
so if you substitute x cubed inside t squared, you're going to get ln t to the power 6 plus 1. Differentiate. No, not t to the power 6. X to the power
It's X,
6.
sir.
Yeah, x to the power 6. Then you need to differentiate x cubed. The thing that you are substituting inside the function, you need to differentiate that. So that's 3x
Times
squared
3x times 3x squared.
minus ln, substitute e inside, it'll be
E to
e
the 2
squared plus 1 times derivative of e
times is
0.
is uh-huh. Oh
So
yeah,
that's your
yeah,
answer.
yeah.
So that's your answer. So which is your answer
Then
here? Is it C?
D1.
C.
Yeah, because you got x to the power 6 there. Yes,
Mr.
correct.
Teacher, I have a question. Why we again multiply by 3x squared? Sorry, I missed
No,
out
no, no,
this.
no. We're not multiplying by 3x squared. It's a rule that when you substitute the upper boundary inside, if you're differentiating an integral and it's evaluated at two different points, if you substitute the upper function inside, you got to differentiate that function as well.
Because
Yeah.
if you not do it, you will choose the D1. Yeah, if you will not do
Yeah.
that.
Mm.
Yeah, okay.
Right. So basically, that's your general rule. Example, d dx of integral a and b. Those are function a of x, b of x, f of x. Just call it f of x. No, it won't be f of x now because these are x values. It will be f of t dt. So if you have something like this, differentiating an integral, you're going to substitute the upper boundary inside f, inside t. So it become f b of t times b prime minus f a of, right? A of x. Why did I say t? It's a of x. A of x times a prime. Okay, that's your rule. Don't forget that. It's called fundamental
Okay,
theorem
thank
of
you.
calculus rule. Right, you're welcome. Right, so now we have slope fields. Let's observe the slope field. We got -3. So maybe you can take some interval. Maybe you go here is 1. Okay, so now it's equal interval. That's good. That's -3, -2, -1, it's -2, and that's -1. Now, how is look at the slopes on the x-axis, all zeros. Can you see? The slopes on the x-axis are all zeros. Are we good? So let's go. Because the slopes on the, so I would like to do this. X, Y, and M is the slopes. Or Y prime. M is equal to Y prime, which is a slope. Okay. I'm evaluating it at different points. I like to do this now. So I can start eliminating. So now I'm choosing different X values. At -1, Y value is 0. At -2, Y value is 0. My slope is 0. -1 times 0 is 0. No. No, you don't multiply those because we don't know whether to multiply or not. So if I, the slope at -2, the slope at -2 and 0 is also 0. The slope at -1 and 0 is also 0. I'm reading off the x and y values and the slopes from the given function. Now, let's see, can I divide by 0? Can I say -1 divided by 0 to get 0? No, I can't. So I can't divide by y value 0. Okay? So those two options are out. Are we good?
Yes.
Okay.
Right, let's go to -1/2 and 1/2. You can see the slope is negative. For -1/2, let's look at this point here and that point here. Can you see the slope is negative? So if I choose -1/2 or choose -1, -1 in that case. Okay. If I choose a point -1 and -1, I'm looking at this slope over here, which is downsloping. So if I choose -1 and if I choose -1, I know the slope is negative. Can you see?
So it's D.
Can it be -1 times -1 is positive, so it can't be C. Excellent. The answer is D. See how easy it is to find slopes, slope fields.
Easy.
Interpret the difference. Yeah, of course it's easy. Right, let's look at 23. Using the U substitution, U equals x plus 1, right? Dx is equivalent to, now it's very important. Look at the options that they gave us. If you use U equals x plus 1, so if U is equal to x plus 1, du is equal to dx. Okay?
B.
B1, yeah,
No,
just B,
No,
logically.
wait. Hold on. What is x? That's u minus 1. Be careful what you are doing.
No, you
So what is this?
differentiate. So du is equal to dx. So
Yeah, so
hold on.
what's the integral? How are you going to
We
eliminate
have
the
a
x?
x. We have a x. Yeah, we have a x.
What is x? X is u minus 1. Okay, so now you got a problem. U minus 1 over root u. That's easy. Du. So now you got u over root u. So that's u to the power 1 over u to the power half minus 1 over u to the power half du. That's easy, man. Come on. What's u to the power 1? You divide by u to the power half. U to the power negative half, because 1 minus half, minus u to the power. No, that's u to the power positive half. And that's u to the power negative half. You just use splitting. Where's the answer?
C.
Yeah. What was difficult about this? Nothing. That's how you're going to evaluate this integral. Okay?
Mr.
And then obviously,
So when you differentiate, it's like
Not-
you split the function. You made u over root u minus 1 over root u, right?
yeah, because what is x?
Oh, yeah,
X,
yeah.
I'm substituting
Yeah,
the
yeah.
formula. The
Yeah,
value
you
for x
solved
is
for
u minus
x.
1.
Yeah, used u equals
Yeah.
x plus 1, so that means x is equal to u minus 1, yeah.
Yes, correct. And x plus 1 is u. So you just split like this and solve. When you have many terms over a single term, you just split the integral and you solve it.
Yes.
All right, let f be the function defined by all of this. For what values of x does f have a removable discontinuity? Now, I want you to focus on this note. I want you to factor the top. This is more like pre-calculus, right? So if you factor the top, you're going to get 2 into x squared minus plus 7x minus 8 divided by, you can factor the bottom, right? X minus 1, 8 and 1, right? X minus 8. Are we good? Now you can factor the top as well. So you got 2 into x and x.
Positive 8 and negative 1, yeah?
Positive 8 and negative 1. Good. X
So cancel out.
minus 8.
No, we can.
Wait,
Yeah, we can.
very important. Very important. You can only cancel out. Now, whenever you cancel out stuff, if you cancel out the x minus 1 and the x minus 1, then it has a removable discontinuity. So because you're removing the factors, it has removable discontinuity at x is equal to 1. Okay.
So B is out.
No, if you're removing the factors, then removable discontinuity at x is equal to 1. So what type
Yeah,
of
so
discontinuity
the
is
answer is B
at...
is out.
Good, I'm asking a question. What type of discontinuity is at x is equal to 8?
Jump.
No. Infinite.
8. Infinite.
In-
Infinite, yeah.
Infinite discontinuity, or there's a vertical asymptote. Infinite discontinuity or
Okay.
vertical...
Why? Because it goes from negative 8 and plus 8.
No. There's a vertical asymptote. Bas. Vertical asymptote. The graph can never ever touch at 8. So if you have some graph at x is equal
yes.
to 8 is a vertical asymptote.
Yeah.
And at
The
x
one
is
would you
equal
have
to
jump? One would you have jump discontinuity?
jump, you will have when there's split functions. This is not a split
Ah.
function. Okay.
Okay.
So what's the answer? At x is equal to 8, we got what type of discontinuity there? We said it's infinite, so
Infinite.
vertical
So
asymptote.
the answer is
So
A.
the answer is A, 1 only. X is equal to 1 only. Good. You understand why it's removable? Because you are removing
Yeah.
those factors. You're canceling out the factors. Good. Whenever you try to cancel out factors, it's removable. The name suggests it.
Teacher,
Yeah, so let's
if
look
it will be like positive 8, then it will be 1 and 8.
the bottom one. If it was also
The bottom
positive at
one
the
will be
bottom,
positive 8. Yeah.
yeah,
Yeah,
then
but
it will
because
be
it's
both.
removable.
But
you
you're
cancel out.
removing both of, yeah. If you cancel out the factor, it'll be removable. Yes, correct.
Yeah, then it will be D. Okay, let's
So
go.
basically, what and how do you identify a removable discontinuity on the graph? You see the graph as a whole. Okay.
Mhm.
Yeah.
Is it the one that's filled out?
No, the one that's not
The one
filled.
that's empty. Okay,
Yes.
okay.
Let's look at this now. Which of the following is a solution to the differential equation? Now, the thing about these types of questions is you have to differentiate each one, put it back into the original function and see if it works and make sure the answer is equal to 0. Let's try the first one. So y prime is 2e to the power 2x. Are we good?
Mm.
And
Yep.
y
Okay.
double prime
Is 4.
4e to the
4e2x.
Very good. Excellent. Everyone understands that. So now you got 4e to the power 2x, which is y double prime, minus 4 times 2. So that will not work. That is not equal to 0, right? So option A is out.
Wait. 4 times.
4e to the power 2x minus 4. Oh, it's 4y. Sorry, it's 4y, not y
Yes.
Yeah,
prime.
4y.
It does
Yeah, that's
work.
what
4 raised
confused
to
me.
2x.
Yeah,
So the
equal
answer
to
is
0.
yeah, the
That's
answer
it.
is A.
I'm done. Yeah, that's it. I'm done. I'm not going to bother testing the rest of them. Okay, it's not going to work. Right. So since that first one worked, that's it. Done. Right. Let's move on to the next question. The table above gives values of the continuous function f as selected values of x. So what did they tell us about the function? It is just
Continuous.
continuous. If the function is continuous, it does not mean that it is differentiable because you can have corners and stuff. All right. So the table above gives values of the continuous function f as selected values of x. If f has exactly 2 critical points
What does that
on the
mean?
open interval 10 to 4, it means critical points means it has turning points, relative
Oh,
minimum
so
or maximum.
maximum and
Yeah,
minimum. Yeah.
Yeah, so it means f
relative.
prime of x equals 0.
Critical points means relative minimum and maximum. Yes, f prime x equals 0. Good. Now, now we need to check which of these options are correct. Now, in order for me to check this, I'm just going to draw a graph, right? Actually, not this graph here. I'm just going to look at the x-axis. It's a continuous x-axis. Maybe 0 is somewhere around here. So 10 is here, right? Let's look at the y-axis as well. Because just few values, right? 10, 11, 12, 13, 14. All right. So what are these values? Just simple values. 2, 3, 4, 5, and 6. Because this question was a bit tricky. I need you to check. Right. So now when it's 10, it is 5. Okay. When it is 11, it is 2. So there's a drop down, right? 2. When there's 12, it is 3.
It's 3. It increases a bit.
Yes. And when it's 13, it is 6. So it's right up. And when it's 14, it is back down to 5. So now, remember, I'm just drawing a simple continuous function that I know. It's not just a matter of joining the dots. All right, so I'm just going to join the dots for now, but it's one of the infinite options of the graphs that I'm going to draw now, right? There's many options of the graphs because you can draw a graph like this. The most simplest way, I will draw a graph like this. But now we don't know what is happening between 10 and 11. They told us it's continuous. The graph can go like this and then turn here and then go up, isn't? It can do this because it's
Yeah.
continuous. So in between 10 and 11, you can go and have corners and, you can have many things. Now, the simplest thing over here, I just drew a simple function here. Now, if f has exactly 2 critical points, so I'm just assuming maybe there's a critical point at 11, right? And there's a critical point at 13. I'm just assuming, right? Now, let's see which option is the best option. Must be true. It must be true. Must be means it's guaranteed to be true, right? So f of x is greater than 0 for all x in the open interval 10 to 14. No, what did I tell you? I told you I'm just drawing known functions. So I can go and draw between 10 and 11. I can have a function like that, come back up here, turn it here and go up. Isn't? I can do that.
Yeah.
So this is wrong. F of x is positive. So this is wrong. Right, let's look at the next one. F prime x exists for all x in the open interval 10 to 14.
No,
In
that's
the
false.
open interval 10 to 14, f
Because
prime
there will
x.
be horizontal tangents at 11 and 13, so you can't differentiate horizontal tangents.
11
So it,
and
so it won't
30,
exist.
not
You'll have
horizontal
horizontal
tangents. You
tangents.
can wait. You can have corners. In other words, vertices. Because remember, at vertices, at
Yeah, the
corners,
slope will
when you have
just
a
be 0.
yeah.
So you can't differentiate
Listen.
0.
No, I'm not talking about that. I'm talking about corners. If you have corners, at the corner, the graph is continuous, but it's not differentiable at corners. Example, absolute value function. At this point here, it is continuous, but not differentiable.
Yes,
So
yes,
you
I
may
know, I
have
know.
corners. Right? So because of
And
corners,
also because of the horizontal tangents.
yeah. What about f prime x is less than 0 for all x in the open interval? This is also
No,
false because I can go
it
down.
And you
I can
might,
go-
and you can go up as well.
I can go up, yes. So it's not necessarily negative, right?
Yeah.
The graph is not always what they said. F prime x is always less than 0 for all x in the open. You can already see this graph
Yeah,
between
there's
10
it's
between
not
10 and
yeah.
11 between 10 and
It's concave
11.
up.
I don't know what's it. Wait, you can't say that. Between 10 and 11, I can draw
Oh,
multiple
yeah,
graphs.
yeah, yeah.
Remember, this is just one of the graphs I drew of a continuous function. I can go down, then go up, and then come back down and turn it, and then go multiple ways. So even this is false because it can be increasing. So the only option that we are left with is option D, and that's correct. Why? Because f prime 12 is not equal to 0.
It's at the corner.
F prime 12.
Yeah. Oh, yeah, because it's in the middle, isn't it?
Yeah.
If it
It's-
will be in the
it's-
end like F11, then it will be incorrect.
Uh-huh.
Yeah,
So the
you mean, yeah, you understand what I say? Yeah? If, for example, it will be F11 and not equals to
Yes,
0, we
yes,
cannot
because
say
the
that.
slope, yes, because
Exactly.
the slope will be
yeah, we're
0,
looking at the slope. Yes. So
So I
basically
don't
the
understand.
I just use process of elimination to get this answer. But
Sultan, basically, here you have a graph of f. So at the corners, you can the slope will be 0 because you'll have a horizontal tangent at the corner. So like if the question said f prime of 11 or f prime of 13 cannot equal to
Slope.
0, then that would be wrong. But the f prime of 12, we have a slope, so that means it can. There's like no way it can equal 0. So that's correct.
Wait, how about B? F prime x exists for all x in the open interval.
Yeah, we don't
F
know the
prime.
function.
oh
We can draw
yeah. I was talking about corners because f prime x. Look at this. What if I have a vertex over here? Between 10 and 11, if I draw a graph like this, I can explain that to you. It's very simple. Right, look at this. Between 10 and 11, I can go, remember this is just one of the graphs I drew. I can draw another
Yeah.
graph like this.
It can
I
be
can
random
come
points.
down, I can come down,
Mhm.
right? And then I can start doing this. That's another graph. Now, what's happening between 10 and 11? I have a corner. So it does not
Yeah.
exist. F prime x does not exist at that point.
I see.
Yeah. So that's why that option is wrong.
How about C? C is the same thing.
No, yeah, C is the same thing. What they said between 10 and 11.
Yeah.
Oh, no, what they said between 10 and 14, F prime exists, not necessarily because of corners. F prime C, I can have between 10 and 11. They said it's only negative, not necessarily because I can go down and then up. You can see I have a positive as well, positive
Yeah.
slope. I can make a graph with a positive slope. And F prime 12, what we said, I
It's in the
think
middle of
Farooq,
the extrema.
what you mean? No. This
It's
is
in the middle
one
of the
of
maximum
this
and
is
minimum.
this is just one of the possible graphs. Yes. So it has to have like it's definitely not 0. Yes, correct.
So, Mister, what does it mean when it says exists for all x?
It means for any value of x between 10 and 14, f prime x exists. It means that it is differentiable.
Oh, I see.
But now at the corner, the graph is not differentiable. Not differentiable at corners.
So
Mister,
exists means it's not 0, basically.
Can we
No,
can
the
we
f
have
variables p and c change with respect to time. The relationship between p and c is given by the equation p squared is equal to 20 minus c all cubed. At the instant when dp dt is equal to 41 and c is equal to 15, what is the value of dc dt? So this was the original equation. They involved time in it. So obviously we got to do implicit because it's kind of like related rates. Okay. So we got to differentiate this function with respect to time. In other words, p is a function in t, c is a function in t. Right, so let's find the derivative. Okay, finding the first derivative. So p squared is 2p times p prime. What is p prime? dp dt equals, the derivative of this is 3 into 20 minus c all squared times the derivative of the inside, which is negative c prime. Are we good, guys?
Yeah.
Right, so what are we solving for? We're solving for dc dt. We are solving for c prime. Okay. So we have some values given, which means that p prime is given, which is 41. We need to solve for p at the value when c is equal to 15. So if c is 15, what is p? P squared is equal to 20 minus 15 cubed. So p squared is equal to 5 cubed. 5 cubed, which is basically 125, right? So p is equal to 5 root 5. Yeah. So the value of p is 5 root 5. Yeah. So 2 into 5 root 5. What's p prime? 15 is equal to 3. What's 20 minus c? 20 minus c is...
So I thought P prime was 41.
Oh, yes, 41. Sorry. That's correct. That's 41. C 3 into 20 minus c, which is 20 minus 15. C is 15. So that's 5 squared is 25. Times negative c prime. Okay. So c prime is equal to 2 times 41 is 82 times 5 root 5 divided by negative 75. I think 5 and negative 75 can cancel out 25 times, right? Yeah. The 5 and the 75 can cancel out 25 times. So the answer for C prime is equal to
Negative 82.
root 5 over
15. 25. Wait.
no, wait. Not 25 times, 15 times, you're right. Because 5 times 15 is 75 over 15.
17.
That's correct. Negative 82 root 5 over 15. Correct. That is dc dt. Are we good, guys?
Yeah, okay.
Yeah.
Number 28. Is this L'Hopital rule or is it direct substitution? Let's check. What's 2
5
to the power
infinity?
So
not
the answer
infinity,
here
negative.
will be negative 2 over 5 because it's the highest power. You take the
No,
highest
no, no,
power.
no.
Oh, yeah, yeah.
Isn't it?
Sorry.
No. This is
You check, is it?
exponential.
Yes.
This
we
is
should check.
exponential function. It's not x squared, and it's not x.
Oh,
This
L'Hopital.
is
Oh, no.
It can it
Isn't it-
might be 1 and negative 1, so we don't know.
listen.
3 over 4.
Directly substitute first. What's 2 to the power negative infinity? It's like saying 1
It will
over
be
infinity. Yeah, it's like 1 over
1.
2 to the power infinity, which is 0.
Oh, so 0.
And this is also 0, so 3/4.
Yes.
What are you guys
Yeah,
saying,
because
man?
3/4 is 3 to the power of 1 and 4 to the power of 1. They're the both highest power. Yes, would be 3 over 4.
Listen. If you directly
makes sense.
substitute, it's 3 plus 2 to the power negative infinity. And that's 4 minus 5 to the power negative infinity. What is 2 to the power negative infinity? The 1 over 2 to the, which is 0.
Oh, so sorry, if it was x approaching plus infinity, it would be 2/5.
Then it will be
Negative
infinity.
2/5.
No, then your answer will be infinity over infinity. Then you need to use L'Hopital's rule. Yeah. So that's a different story now. So the answer is 3/4. Okay. You are talking about this limit as x approaches infinity. This is a different function. 3 plus, say, x squared, right? And 4 minus, maybe like 2x squared and 4x squared. The powers are the same. It's polynomial functions.
Cancel each other
Then the
out.
answer is
Yeah.
so 2 over 4, which is negative half. You're talking about this. This is not this. This is exponential function. So be careful. They won't give you an easy question like this. They'll always give you something to evaluate. Like,
No, so this is easy. It's just sometimes tricky.
yeah. That's why step 1 is always to directly substitute and check. and observe the type of functions that you have. Right, next one. The graphs of the functions g. The graphs of the function g and the line y equals x. Y is equal to x is the line. And that's a graph of function g. As shown in the figure above, the graph intersects at 2 points, 1 and 2. Which of the following expression give the area enclosed by the graph? So obviously, if you want to find the area under the graph, you're going to evaluate because top function, bottom function. This is g minus the bottom function, which is x. And this is bottom function g, top function is x. Okay. So how can I evaluate the area? So it's g of x minus x, 0 to 1. Wait 1 second. G of x minus x, 0 to 1 plus 1 to 2 is 2 parts. The area needs to be in 2 parts. So it's area 1 and area 2. All right. Now think about it. If you're evaluating the area in 2 parts, it's the same thing as saying calculating like a total distance, not displacement. Okay. Because if you try to calculate the displacement, it's going to cancel out. You'll get 0 because it's symmetrical. So obviously option number 3 will work, right? So what about option number 2? I just talked about distance, okay? So 0 to 2, x minus g of x, absolute value. That's also another way to represent this type of thing. So that will also work. So it's 2 and 3. Theoretical question.
So how is 2?
0 to t of absolute value, x minus g. Absolute value means you can, absolute value of x minus g is the same thing as saying absolute value of g of x minus x.
Isn't that for distance?
Yeah, because you're calculating 2 separate areas, but if you calculate 0 to 2 without the absolute value, then it will areas will cancel each other out. You'll get 0 as the answer. But if you calculate with the absolute value, you're going to calculate from 0 to 1 and then from 1 to 2.
I see.
Right.
So there's 2 ways of doing this.
Yes. Especially when it's area between curves. So 2 and 3 both will work. Question number 30. A student attempts to solve the differential equation dy dx equals xy cubed with initial condition y equals 2 when x is equal to 0. The steps that the student's solution are shown below. In which of the following steps does the error first appear? Let's see. Dy dx is equal to xy cubed. So that will become dy over y cubed is equal to x dx. So the step 1 is to integrate like this. Is that correct? Yeah. And step 2 is to integrate this. If you're integrating this, x squared over 2 plus c, that's correct. This is incorrect, okay? Because the integral of 1 over y cubed is not ln y cubed, okay? The integral of 1 over y dy is ln absolute value of y plus c. The integral of this is integral y to the power negative 3 dy, which is equals to y to the power negative 2 over negative 2 plus c.
Plus c.
So that's step 2 is wrong. So, okay.
So what would be the ln y cubed?
Ln y cubed will be maybe y squared over y cubed. Wait 1 second. Ln y cubed. No, there'll be some other function, definitely not this. Okay. Yep. Right, now let's moving on to part B, which is what did they say? Calculators are allowed, so it's 45 minutes. All right. Graphing calculator is required. Okay.
So is the other one 30 minutes?
No, 1 hour. And this is 45 minutes. So 1 hour, 45 minutes is 45 questions. Right, so now let's see. The graph f prime, the derivative of the function f is shown for -3 to 3. On what intervals is f increasing? What does f increase? Look here. There's 2 important concepts here. No, not going to integrate. The graph is, the function is not given. What does f increasing means? There's 2 important concepts. Increasing, sometimes the multiple choices they use greater than equal to sign, okay? So increasing means f prime x is greater than equal to 0. strictly increasing. When they say strictly increasing, then
has
it
to be greater than
means
0.
has to be greater than 0. Very good. So sometimes they use this word increasing loosely defined. So strictly increasing has to be greater than 0. Good. Now, that's what they have. The concept that they have used here is increasing. Increasing means f prime x is greater than. So when is the graph positive here? This is already the graph of f prime. When is it positive? Positive means above the x-axis. So that's where the
Negative
graph of
1
f
and
will
2.
be negative 1 to 3. The graph ends at 3. Why
Oh,
you
yeah,
said
because
2?
oh, yeah.
The
No,
graph
it's
ends
I
at
thought it
included,
was
yeah.
stops here.
so 3 will be included as well. Yes. So it's
Mhm.
from negative 1 including to 3 including.
So B.
Yes. Is
But
there
So
any
why
other
did
usually
option?
they will say
why would they
one
plug
question,
in
so
negative 2?
What is that?
Why do they have like negative 2 as the answer and everything?
No, the strictly increasing answer will be from negative 1 to 2 union 2 to 3.
yes.
That will be strictly increasing.
Okay.
Okay. That will be our answer for strictly increasing. But increasing, they have just combined the intervals. So just be careful. Obviously, it can't be from negative 3 to negative 1 because that is decreasing, is below the x-axis. F prime x is less than
Yeah.
0. We're looking for when the function f is increasing. F is increasing when f prime x is greater than 0. Well, we already have the graph of f prime, so above the x-axis. We're not looking for increasing and decreasing on this graph. Be careful. Don't ever take increasing and decreasing on this graph. You need to check what graph is given first. Very important. And let's continue. Wasting time here. Next question. The rate at which water leaks from a tank in gallons per hour is modeled by R. So what is R? What's R? The rate.
The rate.
And what is it measured in? Gallons per hour. Are we good? A differentiable function of the number of hours after the leak is discovered. Which of the following is the best interpretation of R prime 3? What does R prime 3 represent now? Do not read these things. Just tell me what R prime 3 represents. The R is already the rate. Then R prime 3 will be gallons per hour, isn't? Per hour squared.
Yeah.
Gallons per hour squared. Very important. Now, let's see which information makes sense. The amount of water in gallons that has leaked out of the tank during the first 3 hours after the leak is discovered. What is amount of water? That is volume, which is gallon, which means they are doing an integral.
Yeah.
Okay. So it
So
can't be
that's not
option A. That's wrong. The amount of change in gallons per hour in the rate at which the water is leaking during the 3 hours after the leak is discovered, the amount of change in gallons per hour in the rate at which the water is leaking during the 3 hours after the leak. Okay, I'm just going to hold on with that. Little slight confusion. I will explain. The rate at which the water leaks from the tank in gallons per hour 3 hours after the leak is discovered.
Could that be it?
No, I'm just checking. The rate at which the water leaks from the tank in gallons per hour. The rate is wrong here. It's not gallons per hour. We said it's gallons per hour squared. The rate of change of the rate.
Oh, it's D.
So this, let's see, the rate of change is derivative of the rate at which the water leaks from the tanks.
Yes, mister.
In gallons
It's
per hour
D.
per hour, so it's D.
In gallons per hour power. Yeah, so perfect. That's the one. Because the rest of them
So
are
what's
giving
B
us all.
talking about?
Yeah, that's what I'm trying to say. The amount of change in gallons per hour. Well, the rate is wrong. Gallons per hour. They're talking about R of 3 here.
But Mr.
But
what
not
does the
the
amount of
derivative
change
of the
mean?
RF3, yeah?
Sorry?
But not the derivative of the RF3, but we need
Yeah,
the
the
derivative.
last one. The last one is talking about derivative. It's more like they're
So-
talking about the acceleration. How fast is the
Yeah.
water flowing? They're
So what
talking
could
about
the
how.
amount of change mean?
What is that? Amount of change. The amount of change in gallons per hour. That's what they're talking about. No, amount of change in gallons per hour.
So that's just delta.
Yeah.
I guess. Yeah.
Yes. I think it's delta. I think it's R of 3 minus R during the 3 hours. So it's R of 3 minus R of 0. That's what they might be talking about.
Oh, so it can't be B. Yeah, so it's D.
Yeah, so the answer is D there. Yeah, so theoretical question. A particle moves along the x-axis. The velocity of the particle is given by this. If the position of the particle is x equals 1, when t equals 2, all right, what is the position of the particle when t equals 4? I think you got to integrate here. Oh yeah, isn't it calculators are allowed? Yeah, so we can integrate this. Yeah, so we can integrate this. So we are finding from 1 to 4. Integral from 1 to 4. Integral from 1 to 4 of v of t dt, right?
So how's it from 1 to
Which is
4 when
basically,
x is equal to 1 to t is equal to 4? It's two separate variables.
oh no, from 2 to 4, from 2 to 4. Thank you.
Mhm.
Should be from 2 to 4 because t is equal to 2 and t is equal to 4. So it should be from 2 to 4. Now the integral from 2 to 4 of v of t dt is the same thing as saying the position. Isn't if you integrate the velocity? If I use fundamental theorem of calculus, if I
Yeah.
integrate the velocity, I will get position.
Position, exactly.
So I will get s of 4 minus s of 2. Okay? What do we need to find? We need to find s
S
of
of 4.
4.
So
We're finding
S,
s of 4. What's s
so
of
plus
2?
1, basically.
What's s of 2? 1. So we add 1 on that side. So it's 1 plus integral 2 to 4. What's v of t? 4 over t cube plus 1 dt. Someone do this on the calculator and give me the answer.
Mhm.
Because
Give me a
calculators are
second.
allowed. You're not going to waste your time solving this integral
Okay,
because it's going to
give me
be
a second.
partial fraction. You understand? It's going to be integration by partial fractions, which is in the B
It's
task, not in the.
1.35, basically.
You got 1.35?
Yeah, so C.
So this answer is equal to
Yeah, it's
1.3
1.35.
1.353. Thank you. Next one. This one here. This is the easy question. It's just basically what you
Discontinuities.
call yeah, continuity,
Yeah,
discontinuity, and
continuous but
function.
not differentiable.
Very important. The
It's
graph
in
of the
between 2 and 3 because there's a corner.
1 second. Wait, 1 second. The graph of the function f is above. Right. So which one of the following intervals on which f is continuous but not differentiable? When is it continuous but not differentiable? You see, there's a corner
In
here, so
between
it's
2
not
and 3, yeah.
differentiable.
There's a corner.
Yeah, good. So it's
So
not
why is the corner
differentiable
not
at.
differentiable?
Because you'll have a horizontal
Okay.
tangent. The slope of
Okay,
a
now.
horizontal tangent is 0.
Okay, let me explain it to him. It's a very good question. Just no, listen. Why the corner is not differentiable? See, f of x is equal to absolute value of x, right?
Yeah.
What is the absolute value of x? X if x is greater than or equal to 0, negative
Or
x
X is less than 0.
if less than 0. Good. Now let me differentiate this. What's f prime? Now what is the graph of f? Isn't the absolute value of function is simple?
It's a V graph.
That's the absolute. It's a v graph. Good. Let's draw the derivative graph. What is f prime x? It is 1 if x is greater than 0, negative 1 if x is less than 0 or greater than
Is it
equal
greater
to.
than, okay, equal to 0, yeah.
Right. Now let's draw this graph here. What's the graph of 1 if x is greater than or equal to 0? It's at 1 horizontal line.
Mhm.
And
Yeah.
negative 1 is here.
X is less than 0.
So now you understand.
Oh,
You see what
I
happened?
see.
Yeah. So corners are most likely like different functions. So when you differentiate them, you get different values. So at corners, the graphs are not differentiable.
So corners are always split functions.
Not
basically.
differentiable. Yeah.
Yeah.
Corners, the graphs are not differentiables. Right. So it's never
But
ever
they're
different. So the
continuous.
answer is yes, because there is a value at that point, but the derivative does not exist.
Yeah.
Most likely you'll get jump discontinuities at corners.
Mhm.
Right. So now between 2 and 3, it is continuous but not differentiable. So the only possible answer was 2 and 3. Are we good?
So what about the situation with 3 and 4 and 1 and 2? What's happening with
Okay,
that?
okay. Let's look between 3 and 4. The graph is discontinuous. We're not looking for the.
Mhm.
We're looking for continuous but not differentiable. So
Yeah.
between 3 and 4, that option is wrong. Between 1 and 2, there is a discontinuity, removable.
Is it removable? Yeah. So
Yeah.
3 and 4 is jump discontinuity.
Yeah.
Discontinuity.
Yeah, and then at 0 and 1, the graph is
It's
continuous
continuous.
and it is differentiable. And
Yeah, yeah, yeah.
differentiable because it continues increasing, right? So
Mm.
we are looking for not differentiable, but continuous.
So 2 and 3.
So it's only between 2 and 3, correct? Hope you understood that. Right, excellent, guys. Yeah, next question. The first derivative of the function f is defined by f prime x for -5 to 1.5. On which of the following intervals is the graph of f concave up? The graph
Put
of
it
f
in
is concave
graphing
up.
calculator. Put it in Desmos.
Oh yeah,
Can
we'll
use
have Desmos
Desmos
Uh,
with this.
during test.
Yeah.
Okay, okay.
Just use
Yeah, yeah,
Desmos.
yeah. Look. We got a problem because -1.5 and 1.5. What about other values here that they're giving us? So there are other values. So graph of f being concave up means where this is
F
increasing and decreasing.
F double prime of x is greater than 0.
F double prime x
Is
is
greater than 0.
greater than
Greater than
0.
0 means it's concave up.
It means that it means that I'm looking for the increase on f prime, whereas
Yes,
f prime
increase
is
on F
increasing,
prime. Increases, yes.
and
Oh.
f double prime x less than 0 means I'm looking for a decrease.
It's negative slope.
No, no,
Decreased
okay, so
function.
I'm looking for, but now I'm not looking for this. I'm looking for the first option. So I will put it on Desmos to see what this graph is between -1.5 and 1.5. So x squared plus 1
Shouldn't we
sine
integrate
3x.
first
No
But
need to
why
you
integrate? We'll
can't.
just use
to get
Desmos.
the function so we can put it in Desmos?
No, wait, one second. Let me explain to him. You can't integrate because you're not looking for concave up. What does concave up mean? Double derivative.
Increasing.
Why are you integrating?
Oh.
You
I
got the
see, I see.
derivative function. You need concave up. You're looking for double prime. In other words, where
Yeah,
f prime is positive, right? So between this interval, I need to look for when it is increasing. So I'm gonna put this in Desmos and check when it is increasing and decreasing. I think I did it.
Go back. Let me just see the function again so I can write it down so I can tell it to you.
X squared plus 1. X squared plus 1 sine 3.
Sine 3x minus 1.
Yeah. Sine 3x minus 1.
What the hell? Yes.
Wait, one
Negative
second.
half to 1/2.
No.
1 and 1/2, I mean.
I'm going to change the boundaries. So I'm going to put -1.5. -1.5 x-axis to 1.5, right?
Yeah.
Radians,
I
of
already
course.
know what the answer is. The answer will
No,
be on
listen.
this side.
Wait, one second. We are looking for an increase, okay? So from -1.5, you can see looking for an increase. 1 second. Let me take this graph out for you guys. Right, so between
So
1.5 and
increasing
1.5.
from
1 second.
wait, this is weird.
This is the graph of f prime, right?
Mhm.
Now I want you to look at this graph and tell me what the answer is. 1 second. You are looking for increase and decrease. Very simple. You're just gonna match it up with the options here. Okay,
So
let me take
see.
that part off. 1 second. Wait.
Wait,
Where's the
wait.
increase? Where's the increase from -1.5 to somewhere around that point?
No,
You're
so
gonna
we're
start.
looking for a positive slope.
Yeah, so this is positive slope, sloping up. It's up
Oh,
sloping.
okay. But then it
Right,
stops.
so that's one piece here, somewhere there. Then maybe from here it starts again, another slope going up. Then it stops there. So there's only
So
two
A.
parts to the answer.
I
Is
see.
it A?
Yeah.
-1.5 to -1.34. -1, yeah, good. -0.24 to
To approximately
somewhere.
0.96. Yeah, it's A.
Right, great. What about this one here? The rest of the, did you guys check the rest of
The
the
rest are
options? It's
wrong.
nonsense.
Yeah,
Okay,
yeah,
great.
yeah.
Right, so
Teacher,
that's the one.
I have a question.
Yes.
We say that it's concave up about the double prime, but this is
No.
one prime graph, f
Yeah,
prime
yeah.
graph, isn't it?
So if it's f prime, if you're looking for increase on the, f prime, it means double prime is greater than 0.
Oh yeah, yeah. No need
Remember,
for
concave
differentiate.
up. Yes, concave up means this part here. Okay, this is the meaning of concave up. Now, in order to get that, you need the increase on the f prime. So no need to differentiate. Yeah.
Teacher, how are you gonna solve it without decimals?
Okay, 1 second. Good question. You're gonna find the double derivative though. F double prime x is equal to
Why
f
make your
double.
life more difficult, Farouk?
But
1 second,
not all.
Product rule.
Do you know how much costs graphing calculator in the Amazon? 600 reals, bro. What do you mean?
Okay,
Bro,
okay. 1 second. Listen.
I bought mine and I don't even use it, bro. You have Desmos.
Look, you're only gonna get like maybe 1 or 2 questions using graphing calculator in this scenario.
What?
But look, there is a way to check which options are correct, right? So what I'm going to do is you're gonna substitute different values. Look at f prime x, okay? I'm gonna look at f prime x and look at the intervals that they gave us from the multiple choices, all right? I'm going to substitute into the values into f prime x, right? You asked me how to solve it without Desmos, so there's it here, negative 1.5 and 1.5. What are the different values that they're giving us? Negative 1.341. What's the next value giving us? Negative 0.24. Right. What's the next value they're giving us? 0.964. Yeah, but this will not tell us the increase and the decrease. It will just give us positives and negatives. 0.964. And they also give us 0.33, negative 0.74. You have to put all these intervals that they gave us onto the number line, then substitute these values inside, right? But that will only give us positive and negative, so that's not going to be it. You have to find the double derivative and then draw the number line and use all these values to check.
So product rule.
Yeah, you have to use product rule too. So you're going to find the double derivative, f double prime x, which is 2x sine 3x minus 1
And x squared plus 1
plus
cosine 3x minus 1 times 3.
x squared plus 1. No, not sine 3x minus cos.
It's a yeah, I said cosine 3x minus 1 times 3.
Thank you. Times 3. Now you're solving for greater than 0. So you're going to draw a number line and substitute different values, right? So you're going to substitute negative 1.5. 1.5. Let's go with option A. You're going to try the different options. You're going to say negative 1.3. 4, right? You're going to try negative 0.24, right? And 0.964. You're going to figure out the signs in between. Substitute any value between minus 1.5 and minus 1.34. So substitute negative 1.4. You'll find that this is positive, okay? If you substitute any value between negative 1.34 and negative 0.24, like negative 1, if you substitute negative 1 inside, you'll find that this interval is negative. If you substitute any value between 0.24 and 0.9, you'll find that this is positive. So you're looking for, in the double derivative, positives and negative means concave up and concave down on f. Positive, right? And this is concave down. And you'll find that this is also concave down there. Okay? Make sense?
Yeah, this is the way, yeah.
Yeah.
Don't worry, mister.
So-
I can give Farouk my graphing calculator. I don't even use
Okay.
it. I'll use Desmos.
All right. Next one. During a
Oh,
rainfall,
thank you.
the
Welcome.
depth of water in a rain gauge increases at a rate modeled by. So what is this? Is this already the increase? Rate increases by the rate. So this is already the rate function, where t is the time in hours since the start of the rainfall, and r of t is measured in centimeters. Yes, r of t is measured in centimeters per hour. How much did the depth of water in the rain gauge increase from t equals 0 to t
So
equals
we
3?
just integrate from 0 to 3.
Yeah.
Basically, wait, let me just do it. 0.5 plus
We can use our calculators.
x. Yeah, bro.
It's easy.
Oh, you think we're Einstein to
Totally.
integrate this alone?
Listen. It's very difficult to integrate that. You have to use numerical approximation. So just integrate from 0 to 3. of 0.5 plus t cosine pi t cubed over 80 dx. Use a calculator.
much
Type
is
all
that?
this up.
I got 5.40.
That's it.
Yeah, so D.
5.401. Yeah, because you're allowed to use a calculator, try to maximize on that, right?
Well,
Mr.
Misa, is your calculator on radians?
Yeah, make sure your
Yeah,
calculator is on
I'm
radians.
using my normal one. Yeah, it's on radians.
Okay, خلاص.
Mr.
Right,
You
let's
know, last year in school,
Mhm.
they let us use the calculator for the whole exam.
Right,
Wallah,
this one.
mister. But then the
Right,
FRQ,
listen.
they took it away. The MCQ, I had the calculator the whole time.
Right, listen. 82. Let f be a function such that f of 1 equals -2. F of 1 is equal to -2 and f of 5 is equal to 7. Which of the following condition ensures that f of c is equal to 0 for some c in the open interval? I think this is intermediate value theorem. Let's see.
Yeah.
Let's draw a graph to see. Let's picture this and see what's happening. F be a function such that f of 1 is equal to -2. So 1 is -2. And f of 5,
7.
yeah, this is -2 and that value is 7 there. All right, so obviously this will be some types of continuous function there. Condition ensure that f of c is equal to 0. So f of c equals 0 is here. That's the value of c that they're talking about. Obviously, this is finding the areas. That's nonsense.
So is it is it C? It's continuous on those from 1 to 5.
F is
Mr.
increasing.
B is
No, it
wrong
needs to be.
because
It needs to be
the graph might be
continuous.
going up and down. The graph
Yeah.
might be going up and down. F is
Intermediate value
continuous
theorem.
on closed interval. Yes, it has to be continuous because IVT it won't stand if it's not continuous.
And there's
One
no
of-
such thing as
yeah.
There's no such thing as increasing on the closed interval.
Yeah,
It
because
needs
the
to be
graph
increasing on
could
the
be
open
going up
interval.
and down.
Yeah, it needs to be increasing on the open interval 1 to 5, not closed interval. So this is also wrong.
Can you just
What
explain
about D,
again?
sir?
Open.
What does D mean?
Open interval.
Open interval means 1 to 5.
No, like how would that be in graph terms? Like how would you graph an open interval?
Like not including the endpoints. You have to sketch the derivatives.
Oh yeah.
Huh?
How is D wrong? F is defined for all x values. F is defined for all x values in the closed interval 1 to 5.
But 1 is not defined, so it's -2.
No. It is defined. F is defined for all x values in the closed interval. What they said? No. What they said for some value c in the open interval. They want the value. F is defined for
It's
all
just closed
values
interval
of.
too.
From 1 to 5.
So
I
it
see what
should
you
be
mean.
open interval.
No. When they're talking about, you need to be talking. You see, these are theorems of IVT. It needs to be continuous on the open interval. Sorry, it needs to be continuous on the closed interval. It's theorems of IVT. Remember, we have studied that before.
Mr. D is
Listen,
wrong. D is
Yes,
wrong because
we found the best answer
if
here.
we say a function is defined, it can be defined, but like the function can still be discontinuous and it can still be defined.
Possibly,
It
yes.
can be defined and discontinuous. So D is wrong.
Yeah. 1 second. Where's IVT? Yes, you need to go over file number 11, right? So when you go to IVT, the theorems, where's the theorems?
Up. The first thing, Mr.
Yes.
Up.
The first thing was here.
Finding rows. No, I think I just defined it. Finding rows in the interval. Yes, it needs to be continuous on the interval A to B. That's
one
that's
of
what
the
I
three
taught you.
laws of
Yeah, one of the threes. Yes. See,
yeah, see, F is
the Roller's
continuous.
theorem. F of x is continuous. F of x is differentiable on the open interval. Those are like all the keywords that you need to look out for. Let's get back here. So this is the best answer. This is one of the 3 theorems that we need to use for the intermediate value theorem, right? So this is one of the conditions. The rest of them are not conditions.
So
Okay.
what does D even mean? It's defined for all values of x in the closed interval.
It means that the value of c can be at either point. It can be Wait, f is continuous on the closing. No, this is not a condition for mean value theorem. It's not a condition. What they're saying is there's a point that exists everywhere, which is not necessarily true.
Mm.
In the closed interval. Yeah, this is not even a condition. D is not even a condition of the intermediate value theorem. When you take out
Yeah.
D, this is a condition. You have to look at the condition in exact words. Right. Anyways, next one. The acceleration of a particle moving along the x-axis is given by a of t, which is t minus 8 sine t for 0 to 8. At what value of t is a particle's velocity decreasing most rapidly?
So we integrate
Wait
from 0 to 8.
one second. Let's try to interpret the question. Particle's velocity, right? Particle's velocity decreasing. That's already the acceleration. Okay? Makes sense?
Yeah, so we can integrate the function and then put the function into Desmos.
No, we're not going to integrate. Listen. We're trying to interpret what this here means. Look at this. The wording is important. What is increasing velocity and decreasing velocity? You're going to use the acceleration, correct?
Mister,
Yeah.
why don't we just plug the acceleration function in Desmos and then see when the slope is decreasing? Because velocity is the slope of acceleration function, acceleration versus time.
Very good. So we're going to plot a of t, but I want to do it without plotting now. All right. Now listen. A of
When
t
the
is t minus
acceleration is the most.
when acceleration is the most, yes. So maximum acceleration means a prime t.
Mm.
Find the derivative. That's 1 sine t. I found the derivative of the first part. That's just 1 times sine t plus t minus 8. Derivative of sine t is cos t, right? Is equal to 0. So you can take this t minus 8 over to the other side and divide it by cos. So what you got here is with sine t is equal to negative t minus 8 cos t. I'm
Where
going to
is
divide
your
both sides by
t? Wait a second. In the beginning you use the product rule, yeah?
yeah, product rule.
But
Derivative
where is
of
your
t
t?
minus
Ah, 1. Yeah, I see.
1,
I
1.
didn't see.
Right, so let's divide both sides by cos t.
So
you're
tan
gonna
t
get
is equal to negative t minus 8.
tan t is equal to 8 minus t. I just switched it around. Solve this equation and give me a value for t.
So sine
I
plus
solved
sine
it
over
2 minutes
cosine.
ago, Mister, using Desmos.
Okay, I will do that. I will do that as well. 1 second. Let's just okay. I'm gonna put it on Desmos as well. T minus 8 sine t. X minus 8 sine x. What was the interval?
0 to 8.
0 to 8.
0 to 8.
So it's between 4 and 5 at its
Mm,
maximum. No?
Bro,
No.
look,
It's 3.1,
there is
3.2, something like that.
there is
Yeah,
also increase between 0 and 1.
exactly.
So wait. Bro, the answer I think is 1.4.
1 second.
No, it cannot be
Ah.
1.4.
Okay, I'm just gonna put this over here for now. Let's try to interpret this. So 0 to 8, okay? 1 second. Right, so let's see what's happening here. Particle's velocity is decreasing most rapidly. So looking for a decrease, right?
Yeah.
Yeah.
It looks like there's a point here somewhere. What you want the value of t? right?
Mister, it at 1.42 because calculate the slope from 0 to 1.42. It will be the most negative, and it's concave.
Mm.
It's concave down as
Yes,
well.
yes, that's correct. That's correct.
And you
And
only
then you
need the
have another
magnitude.
point. Yeah, and you have another point here, right? And you have another
4.42, yeah.
point here. See, you got three
Mhm.
different points. So most rapidly, decreasing most rapidly will be right here. What's the point? It's around between 1 and 2.
1.4. It's
1.42.
1.4.
So B.
And there is another answer here, 4.4. See? Why it can't be this answer?
Because 1.42 is
Because-
like, it's like bigger.
Because over here, the velocity, because it's increasing here.
Yeah, the
Why it
velocity
can't?
is increasing here. Because
Over here is
there will
decreasing
be
most
because
rapidly.
there will be positive slope. There will be positive slope. If they said increasing most rapidly, the answer would be 4.4.
So it's 1.4 here. Good. Right, obviously you need to substitute these into
But no, I thought it was
the,
because
if you
of the size of the concave. That's why it was 1.42. No?
And because, bro, if you were just to calculate the slope from 0 to 1.42, it would be the most negative there. You can tell by the curve.
Yeah, that's what I'm saying.
yes, decreasing.
Yeah.
But no,
Right, next
you're
one.
saying if it was increasing, it would be 4.4. What do you mean?
If they said
Oh, no. Yeah, what you're saying?
if the particle's velocity is increasing most rapidly, yeah, the answer would be 4.4.
Because you got A of dA dt
Yeah, dA
is
dt.
positive. Is positive. We
Yeah.
want dA dt to be negative.
Yeah.
Yeah,
Mhm.
we are looking for A prime negative, so it's going to be 1.42. Correct. Let's move on. Right, next problem. If the average value of the function of f over the closed interval 2 to 4 is 3, and f of x is greater than or equal to 0 for all x in 2 to 4, what is the area of the region enclosed by the graph of y equals f of x, the lines x is equal to 2, x is equal to 4, and the x-axis? What is if the average value of the function over the interval? What's the average value of function? 1 over b minus a, integral a to b of f of x dx. They already gave us this answer. So what's 1 over b minus a? 1 over 4 minus 2.
Yeah,
Integral
1/2.
2 to 4 f of x dx is equal to, they already told us that this answer is 3. The average value of function is 3. F of x is positive, and the area in the x equals 2, x equals 4, there's 2 and 4. So what's the area of the region? Area of the region is
6.
integral 2 to 4. Yeah, that's it. 3 times 2, 6. That's half here. So area is equal
Yeah.
to 6. Easy.
Yeah. Easy.
Next question. The function f is continuous and increasing for x is greater than -1. The table above gives the values of f as selected values of x. Which one of the following is the best approximation for limit as x approaches 0 e to the power -2 f of x? So limit x approaches 0 e to the power -2 f of x. You can just take limit x approaches 0 into the function on the top. So what you're left with is e to the power -2 limit as x approaches 0 of f of x. So let's do that. What is the value of this? They want an approximate value. So what's the value? If you're approaching 0, you're getting very close to 0. There's a 0 here. You're moving away now. So if
Also
you're going
0.
when you are going very close to 0, you're getting these values. So you're literally getting 0. Negative 0.001. You can choose either one. Okay? So you're going to get e to the power -2 times 0.001. If you multiply this out, it's like almost e to the power 0. Approximation.
So C.
The answer is 1, which is C. Just check it out.
Mister,
Put
you know
into
we
the
can use
calculator.
Desmos.
You can use a calculator and get this answer. How are you going to use Desmos here for limit as x approaches 0?
It
How are you going to
works
sketch here? I don't see. You
because
can try it out.
because f of x, you can just say it as y, and then you do linear regression, and then you solve for the limit. It will give you the answer of e to be 1.
Okay. Right. Listen, next one. Let R be the region in the first quadrant bounded by the graphs of y equals cos 4x. So where's the cos 4x graph? I
Cos
think this is
4x
the
will be
top
the
graph.
straight line because
Yeah.
x squared is a parabola graph, and the parabola
that's not
graph
here.
is
Look here. And y equals x minus 2 all squared. That's this graph here, the bottom graph. So this is the bottom
Yeah.
graph, y bottom. So this is yb. And the top graph is yt, which is the cos graph.
Yeah, what is the volume
That's
of the
shown.
solid?
The
Just
region R is the
minus.
base of the solid. For the solid, each cross section, they're talking about cross section. Each cross section perpendicular to the x-axis is an isosceles right triangle with a leg in region R. So perpendicular, so I'm drawing an isosceles triangle here. Right?
So isosceles means 40-45 in that case, the special triangle.
Yeah. The region R, because this is perpendicular to the base, right? With leg in region R. So there's your leg here, right? And there's your leg here. So that's isosceles. Now, what is the height? They said there's a leg in region R. So there's your leg here, the vertical line. Okay. So what's the length of this vertical line? The top graph minus the bottom graph, right? So the leg is equal to yt minus yv. Okay. The top graph minus the bottom graph. Now, what's the area of this? Area is equal to half. What's the base and the height?
The leg and the
Leg.
root leg?
Leg squared, yeah. Half leg squared.
Leg square, yeah, sorry.
So basically the leg is equal to the top graph, which is 4 cos pi x over 4 minus x minus 2 squared. Right, so you got to square this entire thing here to find the volume. So you're going to integrate the area. So the volume is now equal to integral 0 to 2 half 4 cos pi x over 4
Yeah, let me do it.
minus open bracket x minus 2 squared, and the whole thing needs to be squared dx. Okay, you're just gonna let's do it together, right? So you're gonna put the calculator on radians mode. Let me take the half out, so that's 0.5 integral open bracket 4 cos shift pi alpha x over 4 close bracket subtract open bracket alpha x minus 2 squared close the bracket squared
Messi, you
dx
get 1.775.
0 to 2 1.7745
Yeah.
775. Yes, so the answer is A. Right, so you're not going to waste your time
Mister,
integrating that.
There's just one thing I don't understand in the question. I don't understand the leg part. Like, why
let's
is
see.
the leg important? We didn't use it for nothing.
We did. It said for the solid, each cross section perpendicular to the x-axis is an isosceles right triangle with a leg in region R. What's the leg in the region R? The leg is the
Yeah.
top
So how
minus
would
the
the cross
bottom.
section look like in here? Just so I can visualize it better. Can you draw
There's a,
like where the isosceles triangle would be?
there's a cross section here. No, man, you're cutting out a piece here. You're cutting out a piece and you're getting a cross section like this, looking like this. It's a 3D. It's a 3D figure. Let's see. For each solid, each cross section perpendicular to the x-axis
The
is an
area part I
isosceles.
understand. I just don't get how
Okay,
the
okay,
cross
okay.
sections
I got you. I
isosceles.
understand what you're saying. You want me to fit this isosceles triangle in here somewhere. Right, with the leg in region R. What is the volume? For for the solid, each cross section perpendicular to the x-axis is an isosceles triangle. No, because listen. It's easy because you see the leg is in region R, right? And you have a perpendicular triangle. Perpendicular triangle is a 45-45 triangle, okay? So the
Yeah.
base has to be the leg because the longest side is the hypotenuse. So both, yeah, because this thing is perpendicular
Yes,
to the x-axis, right triangle.
Yeah, I got
So
it.
because you're confused about why the base is the leg.
Yeah,
It's because of the
that's what
isosceles
confused me.
triangle. It's because of the isosceles
Yeah.
triangle, and they're telling you it's perpendicular to the x-axis. Next one. Let f and g be continuous function. If 2 to 6 is 5 and 6 to 2 is 7. Okay. This is from 6 to 2. So what's the integral from 2 to 6? Anyone knows? See, if I change from A to B, what do I do?
-7.
I say negative B to A. I take out a negative and make it B to A, okay? So don't forget this rule.
Yeah.
So integral from 2 to 6
Is 7, so that
is
means 6
negative
to
7.
2 is so
Good.
2 to 6 is -7, yes.
So now let's
So then
evaluate this integral.
just
3
substitute.
integral 2 times 6 of f plus integral 2 to 6
F is
of
just
g.
5. F is
F
just
is 5. So 3 times 5.
Yeah. So
Plus-
15 plus 7, just minus 7,
Negative
that's
7.
it.
What's the answer?
wait, integral
What I do?
8,
What I do?
8.
8. Correct. 15 minus 7. There's nothing to evaluate here, just basic laws. Let f be a twice differentiable function such that f double prime x is less than 0. Okay, they're telling us that f double prime x is less than 0. In other words, it's concave down.
So f
Okay.
prime x is decreasing.
Yeah. So basically, f double prime is, in other words, the function f is concave down. So let me draw a concave down function for you, right? So you can understand this better. Okay, let's read the rest of the graph of y equals s of x is a secant line passing through the points 3 and f of 3, 5 and f of 5. The graph of y equals t. Now this is a very important section because they're talking about a secant line, a tangent line, and the graph of f. So everything is fitted onto one graph. So first I need to draw f double prime x less than 0 for you, right?
So what does a secant line mean? What does that say?
Secant line means, explain, it's just passing through the 2 points. Right, so let me draw a concave down function, all right? So there's my concave down function. You can think about a piece of a parabola, okay? Now, what they said, 3 and f of 3. So there's 3 here. So obviously that point will be f of 3, right? And there's another point 5. And that point is f of 5.
F of 5.
Right. Now there's a line that's going, so let me continue this concave down function, right? Now, what they said, y equals s of x is a secant line passing through these 2 points. So a secant line passing through these 2 points is just a line from here to there.
Yes.
Okay. Right, great. So this is s of x. This is f of x. This function here is f of x, all right? And there's another point. The graph y equals t of x is a line tangent to the graph of f at x is equal to 4. So 4 is here. So if you go there, there's a tangent line. Tangent
just
line
like
as well. There's
a line, yeah.
Let's take another color here.
I hate these types of questions, man. Very confusing.
No, not
Same.
you gotta draw it. You gotta draw it. That's how you're gonna get it. All right. So now it's not confusing. You gotta use process of elimination and stuff.
No,
Now listen.
they're easy, but it's just so much stuff you need to do. You might
Okay,
get,
then
you might
okay, what did I
like
do here?
mess something up.
What did I do? What did I do here?
Yeah,
I
you drew
interpreted
the
that as
graph.
concave down.
Yes.
I just interpreted the question. Did I look at the multiple choice options? No.
No, okay.
I did not look at it. Now, what do they want? They want an approximation 4.2. Let's approximate 4.2. To approximate 4.2 is somewhere around here. Let me draw a vertical line. 4.2 is just after 4, right? So you're going to get one approximation on the tangent line. You're going to get one approximation here on the graph of F. And you will get one approximation here on the graph of S. So the S of X is the lowest approximation. So S of 4.2. Where's F of X? In between.
So C.
And where's the tangent one? That's the biggest one.
Above. Yeah.
Uh-huh. So what's
Oh,
difficult
so
here?
this is easy. We just have to draw.
Yeah. You gotta draw
That's
it and check. Come on, man. You gotta draw. You saw every time I did something, I always drew something.
Yeah.
Yeah,
You gotta
it's super
draw and
easy.
interpret and draw.
Mister, you
The
think if
answer
I
was
draw them a smiley face, they might give me a mark?
no. It has to be
They
concave down.
might.
It has to be a sad face. Come on, man. It says concave down.
Mister,
Teacher,
last
teacher.
year in the chemistry FRQ, I said, please give me the mark. I didn't solve a single question.
Alright,
I
listen,
did
listen.
the same thing.
Come on, guys. No time to jokes. All right, so last one. 89. Let's do the last two questions and then we can talk. Right, so the number of insects in a certain population at time t days is modeled by the function p with the first derivative. At time t equals to 0, the number of insects in the population is 40. So they're telling us they're giving us a point 0 and 40, which we can substitute into the equation. Which of the following statements are true? At time t, the number of insects in the population, we got to integrate this function, all right? We have to integrate. We integrate like normal now, right? Because there's hardly anything to substitute. So P of t, we need P of, so if you integrate this, is
Let me do it for
0.3
you.
t cubed
0.3
divided by 3
x
plus
squared
12
plus
t
12
squared divided by
x
2 plus
plus
210
210
t.
from 40
No,
to
not from
0.
40. Hey, wait. Hold on. What are you doing? They said
I'm
at
trying
time
to
t
integrate
equals,
it for you.
no,
No,
Oh,
you think to get the functional.
we need to solve for c plus c, solve for c. So p evaluated at 0,
No,
It's
C must be
40.
40 then.
p evaluated at 0, yeah, so p evaluated at 0 is 40. So 0, 0, 0, so this implies c is equal to 40. Now, after you substitute 40, you need to find p of 10. Now substitute 10 inside this function here. So what's p of t function?
Oh, wait.
One
Let me do
second.
it for you. 0.3.
1 second. P of 10, not 0.3, 0.1. T cubed plus 6t squared plus 210 plus 40. So what's P of 10? You need to substitute 10 inside and
Wait,
see.
you got
Is it no?
0.1 from 0.3 divided by 3, right?
Yes.
So you integrated it, right?
No, yeah, I integrated P prime T from the top.
Wait. 10 cubed plus 6, 10 squared.
So
plus
1 is true, by
210
the way.
plus
So let me do
40.
2.
One
It's
is true.
950, mister.
You're not getting
950.
2840? Are you
No,
not getting
950.
2840?
That's, yeah, it's true. It's true.
No, mister, I'm getting 950.
For
I'm going to
1?
type it off. For the
Yeah,
first
man.
one is
It's
0.1,
950.
0.1 times 1000 plus 600, because substituting 10, plus 210 plus 40 is, hey, 210t, sorry, I think my mistake. Supposed to be a t there.
10T.
Sorry,
Oh,
sorry. 210t, sorry.
Yeah, now it's correct.
Is correct? Good.
Yeah,
So option 1 is true. What about option 2? At time t equals 10, the number of insects in the population is increasing at a rate of 360 insects per day. So just substitute
So
10 inside this.
DRDT.
No,
Okay,
you
wait.
just substitute 10 inside the derivative function, which is given already.
0.3 10 squared
So the
plus
derivative is
12.
like the rate.
Yeah.
It's
the rate.
360, mister. Yes.
Yeah,
Yes,
so it's correct.
360.
So
So
1
it's
and 2
correct.
is true.
Right? What about
So
the third
So
one?
that means, mister, immediately
No
the
need
answer
to
is
do that.
D.
Yeah, but let's just double check third option as well.
At time t equals 10, the rate of the change of the number of insects in the population is increasing at a rate of 18 insects per day.
So basically double derivative.
The rate at
Why?
So 0.6t plus 12. So yeah, it's true.
It's true, yeah.
0.3.
It's 3. Or wait a minute. No, 3 plus 12. 3
What's
plus
3 plus
12. 0.3 times 10, it will be 3 plus 12.
Oh, yeah,
0.6t
double
plus
derivative.
12.
Yeah, you're right. You're right. I'm differentiating the wrong function. It's 0.6t plus 12. Yes.
Plus 12, yeah.
0.6t plus 12. Yeah, so 6 plus 12
So
is
how
18.
do
Yes,
you
right.
know it was double derivative here?
Okay, let's do it.
Oh,
Okay, all right, let's do it. The rate of change of the number of insects in the population is
The rate of change
increasing.
of the number of okay. So
Yeah.
because the derivative function is the number of insects.
Yes.
The rate of change of that is the double derivative.
Yes,
Oh,
correct.
okay.
All right, last question.
No, it goes up until 92.
No, 90.
Wallah.
This was an old
Oh.
paper, 2018. Let's see. So we got all these things here. We got h g of x equals x. What is the value of g prime 7? Very simple. You know what you need to do? Differentiate that.
Mm.
What is h? How are you going to differentiate this? It's composite function. So h
So
prime g of x
times G
G
prime
of
X.
times
G
G
prime
prime X.
Yes,
No need to
nice.
differentiate the x there. It's equal to 1. You need to substitute 7. So it's h prime g of 7
Times
G
G prime of 7. So
equals
G
1.
of 7 from the graph.
G of 7
Oh,
is here.
we don't have G of 7 from the graph.
G of 7. What did they say about G of 7?
See, that's a
If
problem.
G is a differentiable function such that h g of x is equal to x for all x, what is the value of G prime 7?
Oh no, it's h of 22 is equal to 7. So h of g of
Wait, 1 second. H of 22 is equal to 7.
So the inverse of that.
Oh, no, we don't know whether if it's inverse or not. Just hold on. H of 22 is equal to 7.
So that means G of 7 equals 22. So that means H prime of
H
22
prime 10.
is 10. So it'll be 1 over 10. So the answer is B.
No, what do you mean? Come again. What you
H
guys are
prime of
doing?
10. What's the answer of H prime of 10?
Why are you taking 10? G
I
of 7
mean,
is what?
I
What is
mean,
G of x?
G of 7. Wait.
Yeah, it
H
is
of
B.
7 is 22. So the inverse of that will mean G of. Wait, what?
G
H of
prime
7 is
10,
20.
it's saying G prime 10 is 7. So just that's it, I think, yeah. So it will be like
G prime 10. When they say G prime 10 is 7.
yeah, here is it, isn't it? So h of x 10 is 7.
No, it's all h.
It's all H. There's no G.
Oh,
Mister,
yeah.
Mister. So we do H prime G of x times G prime of x. So then if we rearrange this for G prime of 7, it will be 1 over H prime of G of 7. Right?
You know what I
So
think? You know what I think?
no,
I
no.
think
Rearrange
this question.
this.
Listen.
Rearrange this. It's
Uh-huh.
solvable, mister. I solved it. And then, so you would get 1 over H prime of G of 7. So then, if we plug 7, it will be H of G of 7, which is equal to 7. So then we look at H of x equals 7 from the table. So that means H of x equals 7. It will be at H of 3. So that means H of 3 equals 7. So if H of 3 equals 7, it means G prime of 7 equals 3. So that means G prime of 7 equals 1 over H prime of 3, which is 1 over 5. It's C.
Come again.
Here,
Okay,
if you were to
okay, one
yes,
second. Did we do this right?
yes. And then
Right.
after
What's the
this,
next step? What's the next step?
I rearranged for G prime of 7. G prime of
Wait,
7
1 second.
equals
G prime 7 is equal to
equals
1
1
over.
over H prime G of 7.
Okay.
So then if we want to find G of 7, we look at the inverse relationship H of G of x equals x. So that if we plug
1 second. What do you mean inverse relationship of what?
the inverse relationship H G of x will equal x.
Wait.
That's the relationship.
H G of x
equals
is
x.
equal to x.
Yeah,
Yes,
that's
so
what we
then-
told us.
So
Yeah.
h
so then-
h prime
So
of
then if
g of
if
7
we
is equal to 7.
yeah
So h
yeah
prime
if
is 10. So 1 over 10.
no
Wait,
if
one
we
second,
plug
one
in
second.
if we plug in x of 7 we get h of g of 7
Wait, 1 second,
equals 7
If you plug in h of 7,
x of
H-
7 x of
yeah.
7 it will be h of g of 7 that will be equal to 7 because of the relationship up. So then from
You're
the
saying
table
h is equal to g. Then you're saying
yeah, so
basically
that
h
means
is equal
from
to
the
g.
table h of x equals to 7. We look at the table. Which value of h of x will give you 7 when x is 3? So that means h of 3 equals 7, which means g of
Wait,
7 will equal to 3.
Yeah, basically what you're saying is that h of x is equal to g of x.
Yeah,
Because
because
if
of that relationship up.
yes.
So that
Remember
means
f, one
yeah.
second, let me just explain something. F of f inverse x is equal to x. Is f inverse f of x
Is also
is equal to
x.
x. So now if h and g, no, sorry, h is
Oh,
not
the
equal to g.
inverses, yeah, yeah,
They're inverses of each other. So h, maybe this is g inverse. You can say h inverse is equal to g.
Mhm.
Mm.
You can say
So 1
h
over h,
inverse,
yeah.
not 1 over h inverse x. What we're saying
Oh,
is
صح, yeah.
they inverse functions of each other. So h, right, is equal to g
Yeah.
inverse x, or you can say g inverse x is equal
equals
to
to h.
h of x. That's what you can say.
Yeah, so that means from the law up, we need to look at the point where h of x equals 7, and that's 3. So that means h of
So
3.
you got wait 1 second. What's the next step here? 1 divided by h prime.
H prime of no let me explain. So from that relationship, when x
Yeah.
equals 3, h of x equals 7. So that
Wait,
means
wait,
g
wait.
of 7
One
equals
second,
3.
You're going too fast. So when x is equal to 3, h of x is equal to 7, correct?
Yeah, so that means g of 7 equals 3. So that
1 second,
means
1 second. So we substituted 3 here.
yeah,
So
and
we
we
said
got 7.
h g of 3 is equal to
7.
h g of 3. No, that will be equal to 3 in this case.
Yeah, so h
But-
g of 7. No, wait.
Mr. h g of 7 equals to 7. So then
Yeah.
oh,
it
h
would-
g of 7 equals 7.
yeah,
Yeah,
hg of
that's right.
7 equals 7. So that means h. So then we need to look at a value of x, which will make h of x equal to 7. And from the graph, that is 3. So h of 3 equals 7. So if h of 3 equals 7, that means g of 7 equals 3.
Yes, g of 7
So
will
then,
be equal to 3.
so
That's
then we
correct.
substituted back. So then we substituted back in. It will be g prime of 7 equals to 1
So h prime
over
of 3
h
is
prime
equal
of
g of 7, h prime 3.
will be
h prime
equal.
of 3 is
Yeah,
equal to 5.
h
So
prime of 3
1/5.
is 5. So it's 1/5.
H prime 3 is H prime 3 is
Mazel, you're a genius.
perfect, excellent.